Hello, fourth graders. This is Miss Kopp. Today we are starting Unit 5, Multi-Digit Multiplication. Today we're doing Lesson 1, which is Multiplication Arrays. Our learning target is I can understand area models of multiplication for tens and ones. So, you're all familiar with an array. The number of unit squares in an array of connected unit squares is the area of the rectangle formed by the squares. We sometimes just show the measurement of length and width. So what you can see here is the 2 by 3 array, and it has the unit squares inside. I could go ahead and count how many squares there are and come up with 6, in which case my area would be 6. Bigger dots, there we go. A lot of times when we're finding area, we don't put the unit squares in, especially when they get to be bigger, and we would just simply label on the sides the length and the width. So you can go ahead and draw a rectangle for any multiplication equation, and it would be the same. Obviously, we can't do it perfectly, but you could do it as an example. So, next question is, we just saw a 2 by 3 rectangle like we see here. And next to it, we have a 3 by 2 rectangle. Question is, how is the 3 by 2 rectangle similar, and how is it different? Now you can probably see that the orientation is different. One looks wider than the other, and the other one looks taller. That's definitely a difference. However, you will notice that they are the same size. They're just not in the same position. So how do the areas of 2 by 3 and 3 by 2 rectangles compare? Well, if we're to find the area of both of these, I would do 2 times 3. Let's make that bigger. And that would equal 6. Over here, I would do 3 times 2. And we know from the commutative property of multiplication that the order does not matter. It does not change your answer. So in this case, it would also be 6. So how do they compare? They are the same. So how can we apply this? Well, we can do bigger areas with bigger numbers, multi-digit. So here it says to find the area of this 20 by 30 rectangle by dividing it into 10 by 10 squares of 100. So looking at this rectangle, looking at that rectangle, it'd be clear that this side is the 20 and the longer side, the width here, would be 30. So it might not be exactly perfect, but I can go ahead and draw a line across so that I have 10 and 10 to make 20. And then I can go ahead and draw lines to make thirds so that I have 3 10s, which is the same as 30. Again, it's not going to be perfect because we're human beings, and that's okay. As long as it makes sense for you, that's great. So if I go back here, I know that I have 10 here, I have 10 here. We know that 2 10s make 20. I have 10 here, I have 10 here, and I have 10 here. And again, 3 10s make 30. Now to find the total area, I know that 10 times 10 is 100. So I can tell that the area of this smaller rectangle, actually a square, is 100 square units. Here, it's kind of like a multiplication table. I have 10 times 10. Again, that would be 100. So I can go ahead and assume that each box is going to equal 100 since we have all 10s. Now maybe without even having to write all of these in here, you can recognize that, oh, well, since I had 2 10s and 3 10s across, I know that that's like 2 times 3. So how many boxes of 100 are there? There are 6 boxes of 100, which would be the same as 6 times 100. This is now mental math. 6 times 100 is worth 600. Now it did not give us units, so we could just simply say 600 square units, because for area, we're talking about 2 dimensions, length and width. All right, let's try this with some new numbers. Now I'm going to make a model for 7 times 20. Again, this is probably something that you could do in your head, but it's nice to have a visual representation of it. That way we can really understand, well, what's going on here? How does this work? And then when we get into larger and more complex numbers, we can use the same strategy. So I drew my rectangle 7 by 20. Again, it's not going to be to scale, and that's fine. Now I'm going to break up my 10s, and I can leave the 7 since it's already a 1. It's in the 1's place. So I'm going to go ahead and draw a line down the middle because 20, we know, has 2 10s. So we're left with 10 here and 10 here, with the whole thing being 20. Let me make that more clear. Going all the way across is 20. So now what I can see is I can do something like my multiplication chart, and I can do, okay, well, this length is 7, and going across, the width is 10. So 7 times 10 is 70. Same over on this side, 10 again for my width, 7 for my length. 10 times 7 is 70 again. Now if I want to find the total, put all of the boxes together, it's like I have 2 7s, 2 70s, because I have 20. So 2 7s I know to be is 14. Same thing as if you were adding 7 and 7. And then since it's 7D, that would make a total of 140. And that would be our total answer. So making the area model is helpful for visually seeing it, and it will be helpful later on when we get into more complex numbers.